All right, welcome everyone for the last day of PyCon. Today we have a talk by Simone Polcini and Luigi Corollo, and they're going to be talking about doing releases like a pro. As always, remember to ask your questions via Slido. The room is spaghetti. And now give a big round of applause for the two of them.
Okay, thanks guys for being here. We are really glad to the organizer of PyCon, of course, and to all of you for this opportunity that is really important. Let me introduce both me and Luigi. We are, first of all, two, like you, developers, software architect. The rest is really on LinkedIn, but it makes no sense. We think that it's now time to give back some of our actual experience to a wider audience. And most of all, we are a member of GDG Rome, so if you step in Rome, come and join us. We are just members. This is a great community led by three women, Yuna, Rihanna, and Antonella, that are simply amazing. And so let's start on our talk today. What we will see in the next 30 minutes, we will describe a use case that is based on a real-life scenario that both me and Luigi created during the last couple of years during our job activities. We will first cover what is the concept of release management for us and how we aim to automate the software version change, giving the full power to just one person, that is the developer, in a full DevOps style. For us, a total automated way means that you need to take care only of your commit messages. And I think that each one of you that is a developer take care of your commit message. And we describe, of course, a stack, a technology stack that is a big, big one. So please keep in mind that we have just 30 minutes and we will not have so much time to dig into each single component. But at the end of the talk, you will receive a GitHub repository with the whole configuration of the entire stack and 3 Medium posts that will guide you constructing our solution at home. And so now we are going to launch in 3, 2, 1. Okay, let's start from the real world. The real world in software development is, of course, dominated by chaos. At least it starts with a lot of chaos. And we want to make an order in this chaos. And you will see in the slide that there are lots of developers. Imagine a subset of each developers to be developers of single microservices, for example. They want to release their microservice, and each microservice will end in a deploy of a platform that is a set of microservices. Each team knows what they want to release, but they should also know what the other teams are going to release. So we have to speak, we have to avoid misunderstandings. There should be a good release plan with no overlaps, an efficient code-based organization, and a lot more. And this is where our solution comes to help. Let's start from the beginning. We want to store our release version number inside the Git tag. All of you use a Git tab, of course. We want to have a Git tab with a particular format that you see on the right. That is V, and the first digit is the major version number. Then a minor version number, and eventually the third digit is the patch version. We could also have an optional label that will be a suffix of this label, and we will see in a few slides what does it mean. And we want to have this Git tag totally automated. So you don't have to change manually the values that are in this tag, a workflow will do for you. Let's have first a set of rules that can enable the change of the digits inside the previous tag. As you see, we are giving this set of rules inside your commit message. We will use a particular style for the commit message that is called semantic commit message. This kind of style was born in 2011 in a project from Google, Angular, and now it is used in tons of open source projects. You will see that you have 3 lines separated by a blank line. The first one is the most important one. You should start with a type word. The one you see colored are the special words that trigger a release. The other does not trigger release, of course. You can have an optional body where you can, of course, write whatever you want, and a footer that is not mandatory. You can write in the footer whatever you want, or eventually you can write another special word that is breaking change that will advance the first digit of the label I presented a couple of slides ago. Now we understand that we can code the version change inside a commit message, but we now need a tool that is able to scan the commit message to automate this process. This tool is an open source tool. It's called a semantic release. It's written in JavaScript with the Node.js framework. And the most important thing is that this tool defines a life cycle that covers the whole release management process. It also uses a pluggable architecture, so you can extend the behavior of the tool with a lot of plugins that support several languages, Python of course, and several different package managers and build tools. So you can, of course, use in your case pip or PyPI to publish your packages and so on. It's also an open source tool with a great support and a great community. And another important thing is that the configuration of semantic resides in a single descriptor file that you can push on your root. You can also centralize on a repository to push on other projects. This file could be a JSON file or on a YAML file format. And it describes, of course, the flow you decide to implement with semantic release. I stated in the previous slide that there's a life cycle decided by the semantic release implementation. This is the plugin life cycle. Each time that you insert a plugin in your descriptor, in the declaration part, semantic will execute the plugin in the execution order you have declared in your descriptor. And for each plugin, it will trigger a state. Of course, not all the plugins may have implemented all the steps in this life cycle. You will see on the right that we use a few more plugins that enables other behaviors in semantic. For example, the commit analyzer that analyzes your history of commit messages. And you can have also a release node generator that try to auto-produce a changelog based on your semantic commits, the history of your semantic commits. And a GitHub plugin, for example, even if we are in a platform agnostic solution, we assume that, of course, your open source code will be at least on GitHub. And the plugin of GitHub will auto-publish for you the release page. For example, it will link to the tag that semantic generated and put it on your code base on Git. Let me now share with you a few definitions that will help us to understand an example of workflow I will present in the last couple of slides. All of you know what is a protected branch. Is a branch that is a long-lived branch that you can create at repo startup, but of course if you have an ongoing project you can create whenever you need. The most important thing is you will not delete this branch, and this branch will receive a merge from eventually from a feature of a fixed branch where you are developing a new feature on a fix. And when you merge onto a protected branch, you will trigger a special kind of release. We will see in a few minutes. We call pre-beta, main, of course, as protected branches. We call a pre-release branch a particular branch that for semantic will produce a pre-release version. And a release branch is a branch that produces a release version. In particular, a pre-release for us is a kind of release that is for internal use only. You are developing in your team, you want to test. As a matter of fact, you see that the version number, in this case, will be stay fixed during the iteration you do on your branch. And you see that a label, a suffix, will be incremented. So you can start with version 1.02 beta.1, then you iterate again, you got a beta.2, and then a beta.3, and so on. Because version 1.0.2 is a version you will be released to the wider public when it reaches a good stability. Okay? A release is a pre-release that becomes a release, a release that you will distribute to a wider public when you are ready to give to your customers, for example. And finally, there's a concept of a channel that is just a label of a distribution channel. You do not have exactly a channel on PyAPI, but the concept is widespread on other package registry like NPM, for example, or even on Maven. You have special tags that enable you to get the latest stable or beta version, for example. And you can configure semantic to publish on this, eventually on this channel. Okay, and now we are almost at the end of my part. In this slide, we will see a particular way of managing your repository. You maybe know that there are a lot of flows. You maybe have heard the Git flow, the GitHub flow, or the GitLab flow. I strongly suggest you that to see the recipes that are on the semantic release website. There are just a couple of them. We will use for demo reasons the pre-release receipt. In this example, you will see how developers act with your repository when semantic is installed. So you are a developer, of course, and you want to develop a new feature. And you start a new feature, so that needs to be tested, of course. You started making a branch, a feature branch at step 1 from the protected branches pre-beta. You start from version 1.0.11 beta 6. You create your feature branch, your pull request. You remove the draft flag after a few iterations. Now you are waiting for your code review. And at step 2, the code review is okay. So someone tells you that it looks good to him. And on step 2, he will decide that it's time to merge your feature branch on pre-beta, generating a new version that is 1.0.11 beta 7. Please have a look at the fact that we have a new meaning. Merging on pre-beta for us means also that you can trigger a deploy on an environment, for example, the development environment. Then, again, you are done, but your release manager, looking at the calendar, see that the release date has been reached. So he decides that it's time to publish a new stable release. He will open a pull request to merge pre-beta on main, and this will trigger a new release to a production environment with a new tag that is 1.2.11, because the pre-release version is now a release version at step 4. Okay, that's all for me. And just we have a look, because we need at least one slide with an example of code. This is an example of the descriptor of semantic release in YAML format. On the blue lines are just plugin configuration that you can add to semantic to have more behavior added. And the green line are configuration to see semantic acting on branches that are defined as pre-release branch, for example, the pre-beta, or the main branch with the relative channels. And we have also a possible maintenance branch. This is the other strategy you can find on the semantic release site for organizing and managing your repository. Okay.
Okay. Okay. Now we are in the. Oh, aspetta. Okay. Now we are in the part we call it tool. In this part, we will show you how the technology behind our solution. And in this slide, we will show you the approach we have used to make this choice. First key point, we want to build a vendor-agnostic solution. So we select all the open source projects that best fit our needs, the ones with the large community and the most active ones. Then we want to build a cloud-native solution, specifically a Kubernetes native solution, because it's our target environment. It's the most commonly used in microservices architecture. And finally, we use a combination of two best practices, DevOps and GitOps, for design our solution. We'll see it later. Now we show you the technology stack behind our solution. The main core of our versioning system is semantic release, that the one that make the new version. In the left part, there is the continuous integration part with GitHub as the choice for the GitHub repo. But any other solution will work fine. Then there is Tekton, an implementation for our CI pipelines. And in the right, after semantic, there is the continuous deployment part with Argo CD, a GitOps tool that do the deploy to the final destination. In this case, we choose GKE, but any other distribution will work fine, naturally. In the bottom, there is the life cycle of our software. The code starts by pushing in the GitHub. Then Tekton runs the pipeline locally, build the code, the test, the unit test, create the Docker image of our software, then semantic release, read all the commit message from GitHub, and find the new version of our software, for example, v1.0.0, then use this tag to push the image Docker, the Docker image to the Docker Hub, in this case. If our software is a library, for example, use the same version to push to the package manager, for example, PyPy. And then we use this information, the new version of our application, to update the EAC repo the repo dedicated to the deployment descriptor of our application. So Argo CD, the GitOps tool, use this information, okay, about the new version to update the version, the application version in the JKA. In this case, using Helm chart. And finally, we have the pod of our application running in the correct version in the final environment. Now we are talking about Tekton. What is Tekton? Tekton is an open source CI implementation natively in Kubernetes that use a group of building blocks called tasks that implement all the steps of the pipeline. And you can find this task in a large catalog, in a community-driven catalog. You can also use this repo to put your code. We are here to see how it works. Now there is an example of pipeline. We are in Kubernetes. Every task in this pipeline is a pod running in Kubernetes, have access to a config map where you put your configuration, and you can store the state in PVC. Now we are talking about Tekton, the deployment part. Is a GitOps, okay, GitOps tool. Here we have how it works. The developer push the code in the GitHub repo. Argo fill this update and synchronize the Kubernetes with the version we put in this repo dedicated to the deployment part. There is also a notification engine that can use it to notify the new version of application in this in a notification channel like Slack, for example. Now there is an example of a configuration. Okay, there's a kind of application where you can put all the configuration of the notification of our application, the destination, where to deploy our application, the source, the EAC repo, and then a sync policy. And now we have the overall solution here in the slide of our solution. In the left, we have the CI part, and in the right, the deployment part. The flow starts with the developer that push the code in point 1 to the code repo. Tekton fill the notify about this update and run the pipeline. You have the tasks, for example, the clone the repo, then the build, and then there is a semantic task that define the new version of application by reading the commit message, and use this tag to tag the code, push the image to the image repo, and eventually publish in PyPy the same version. Then there is an update task that uses this version to update the EAC repo, okay, with the same version. Then Argo CD discover that there is a new version of our application and deploy to the, for example, dev namespace. And finally, there is the notification about this new application in the Slack channel. Now we cannot do.
I think that we can end here and leaving a few space to your question, because we have a couple of videos that you will find on our repository, and feel free to ask for a version. We have no time to show this couple of videos. They are CI execution. You can, of course.
again, we have a couple of questions, Slido.
Thank you. Thanks.
And I think if we have some time after the questions, you can still show one of the videos maybe. Let's just see how much time there is. But there's plenty of questions in Slido. Keep them coming. Let me just accept a few first. So the first one is, how can you assure that multiple features do not interfere with each other or with the repository management flow, since all the feature branches are merged in the pre-branch?
Sorry.
Okay. So basically, how can you assure that multiple features do not interfere with each other, like with the repository management, if you have multiple feature branches and they're all being merged into the pre-branch?
Okay, this is about the repository management. If you see that you can mix both strategy, the pre-release strategy and the release management, strategy, we have not shown in this talk, of course, but you can, with these two kind of strategy on your repository, you can both have multiple development or multiple version. For example, you can have support to an actual released version that could be 1.2.1, and you have to do fix or new features, while you are developing a future beta version that could be a breaking change at 2.0.0. And you will iterate a lot on the beta version while you are supporting the already released version. Take care of the fact that this question is just on the management of the Git repository. So if you tag each version, you are able to deploy to code without having interferences on released version and pre-release version. I can, of course, we do an example later if you want.
Sure. So another popular question is why or how do you force people to actually follow the semantic commit standard? Is there any enforcement in there?
That's a really good question. Otherwise, of course, if you do not have semantic commits, this is absolutely usefulness. But there are a few tools, for example, that can help the developer. There's one tool I saw in the command line. It's called committed-zen. It should be written in again in JavaScript, but you can install on your CLI. And committed-zen will help you with a few questions each time you want to make a new commit. Okay. There are solutions that can do practically the same thing using just committed-zen, but committed-zen is not born to be put inside a CI workflow. That's why we suggest you to use a tool like committed-zen that guide the developer to redact a commit message without knowing or remembering the format of a semantic commit message. But just used for this kind of operation. Otherwise, you should think that developers should learn, and you have to, of course, dig with this thing. But it's a small one. I think that each one of you write a commit message. It's just, I think it could be easy. We got several teams a job that they're using semantic commits.
Yeah, it might take some time to get adjusted, right? We all know how we are as developers if we have a used routine. But there's several questions on the choice of Tecton. I'm just going to try to summarize them. It's mostly about why you chose to use Tecton instead of GitHub Actions or maybe Jenkins for your tools.
Because we want to be independent, okay, to the vendor of the solution. So we chose a solution that works directly in Kubernetes without any other needs.
Yeah, and maybe back to the commits. Are there any rules about how to semantically write commit bodies in semantic conventional commits? So apart from the commit message, how do you write the body?
No, the body is absolutely free. You can write whatever you want. The first line should be in 80 chars, not more. But in the body you can write lines, and I strongly suggest you to write a few lines, because the body will end in our solution inside a changelog markdown file that is pushed on the root of your repository. Each time you will trigger a release, a new changelog will be auto-added with your commit message and what you've written inside the body. So it's quite useful to write the body if you want. Otherwise, just skip and leave it blank. But it's up to you.
Another question is, what if there are multiple feature branches before merging the beta branch into the main branch? How do you handle that?
Okay, this is again about the repository management, but I have to make you an example that is a little big, but I remember that on the semantic site in the documentation there are 2 pages dedicated to 2 different recipe for repository management. So you can mix both the pre-release version that I presented here and the release recipe to achieve a scenario where you can have multiple versions developed by developers, and you can, of course, scale the solution to develop and deploy on different versions on different environments, and also, if you want, on environments of different customers. Okay, this is require a bigger step. It could be not so easy because you have to elaborate the CI and the Tecton part a bit more. But at least you will have a complete example on the repository, so you can have all the stack up and running. But I'm open to discuss this with each one of you after the...
Yeah. Unfortunately, we don't have time for any more questions. Thanks for all the questions. Again, thanks to Simona and Luigi. And I'm sure they'll be around the conference if you have any more questions. All right, welcome back everybody. Now we have Iga Kaboviak, and she's here to tell us all about the zero downtime migration strategy for SaaS projects. Give a big hand to her, please.
So hello everyone. First of all, thank you very much for being here. Today I will talk about implementing a zero downtime migration strategy in software as a service project. And imagine you are a big player in e-commerce stage like Amazon, and you are forced to take a maintenance break. And last time they experienced downtime, they were losing $66,000 per minute. And we faced a similar problem in Sailor, an open source e-commerce platform. Obviously not at this scale because we are not yet as popular as Amazon, but still the problem is the same. And I will show you how we handled this situation and the obstacles that we faced along the way. So before we start, let me quickly introduce myself. And I came from Poland. I've been using Python in my work for over 6 years right now, and I'm working on Sailor platform for almost 5 years. And I'm happy to see how this project is changing from just an open source project to a proper product. And firstly, I would like to shortly tell you the story about Sailor. So Sailor started as a small open source project built on Django with Views. Then in 2018, the big decision was made and GraphQL API was added. A year later, Django views were totally removed, making Sailor a headless app, which basically means that we started to offer just an API without the front-end side. Over time, Sailor grew up, we gained a community around, and the idea to build a product around Sailor came up. And this leads us to the creation of the full cloud platform that offers Sailor as a SaaS product. Sorry. And as you can see, the story behind Sailor is constant growth. And when you are getting bigger, you are getting more clients, and you are facing bigger problems. And one of oh, sorry, I didn't see that. It's breaking. Oh. It's working right now. Okay, sorry. So one of clients' requirements is the ability to update versions without any downtime. So to sum up the background of the downtime problem is that SaaS clients of e-commerce platform that Sailor is don't want to stop their stores at any time, as of course it means losing money. So we need to ensure that the system is working all the time, even during the updates, and to minimize the migration time. So I think it's safe to say that sooner or later each SaaS application will face downtime problem. So let's move on to some examples. And I will start with showing you the problematic operations, and then we will move to the solutions. So for this talk, I created a simple Django project with GraphQL API and database on PostgreSQL. It's the same configuration as we have on Sailor. And let's assume that we are currently running version V1 of the system. We have multiple app clusters that are using the database. And we want to apply some changes on product type in the next version, V2. And here is the product model on our current version, V1. The product model, the model is just simple Python class that refers to a single database table, and the class fields refers to the table columns. And in simplification, it's basically what object relational mapping is. So let's assume that our product model have a name, description, and created fields. And on version V2, we want to add new Slack field that will be a human-readable identifier of our product. And additionally, we want to rename field created to created at to be consistent with other parts of the project. So as we previously stated, we are currently on version V1 of the system. And let's assume that we released mentioned changes in the next version V2, and we want to upgrade to this version. So upgrading app instances is easy. We simply need to gradually replace old instances with the new one. The problem is with the database, because it's shared resource and we cannot just clone it and replace it. Instead, we need to modify it in place. So we will begin with migrating the database to version v2. And as a result, we'll be in the stage where the app clusters are on version v1, but the database is already on version v2. And once the migrations are completed, we can start the app workers of the next version v2, and then finally shut down the app workers of version v1. So the two stages that we should worry about are 2 and 3, where we have the upgraded database, but still running workers on the previous versions. In other words, we have the old code that is using the upgraded database. And we analyze these stages in the following examples. So let's move on to the problematic operations. So we'll start with adding a unique Slack field that will be human readable identifier of our product. Okay, so what you see on the right is Django migrations. And for those who don't know, migrations propagate object relational mapping changes into the database schema. Simple speaking, database needs to know that something has changed in the models. And migrations allow to define operations that will be performed on the database, but also allow to call some Python function that will make updates on instances. And to add a unique field, we need to firstly add a new label field. So basically, we will create a new Slack column on the product table in the database. Then we need to update existing instances to set the proper Slack values. And we will call the Python function that will do that synchronously. And after the function is finished, we'll have our new Slack column filled in with the proper unique values. And at this point, we'll be ready to perform the last step, which is changing the Slack into unique. So to apply this change, we are just altering the Slack column on the product table. So let's assume that we release these changes in version v2. We upgrade database to this version, but we are currently on version v1 of the system. So when the API request for product creation is called for second or subsequent time, the integrity error is raised. And the error message is saying that the product with empty Slack value already exists. And this is because version v1 is not aware that a new unique Slack column was added, and it's trying to save the row with null value for the Slack. And below you can see the part of the product table that is showing described situation. So we have 2 instances with proper Slack values and 1 with empty value as a Slack. So adding the next row with an empty Slack is causing an error, as the values won't be unique anymore. So we'll discuss the solution later. And now let's move on to the second operation. That is renaming a field from created to created at to be consistent with other part of the project. And seems to be pretty simple operation. We just need to rename the column from created to created at. But it might be problematic as well. So as before, let's assume that we release mentioned change in version v2, and we update the database to this version, but we are currently on version v1 of the app. So as we can expect, when the API request for product creation is called, we received an error. And the error message indicates that column created does not exist on product table. And this is accurate because we renamed this column, and in the database there's only created at column at this moment. However, the version v1 is not aware that something has changed, and it's trying to save the value on the old created column. And we will get similar error when trying to retrieve the product from the database. And this time, the API is trying to fetch the data from the created column, which does not exist anymore. So now let's move on to the last operation that we'll discuss today. And let's suppose we have a large data set of products, perhaps 1 million or more. So updating all instances will take significant amount of time, no matter how hard we will try. So the problem is that the update is blocking the migration process, as we need to wait for the update to finish to continue with the database migration. It also logs the database tables and keeps the database in the unstable stage, which may result in slowing down the application or even make it unresponsive during the update. And as a result, it significantly extends the time of database migration. So these were some of the problematic operations in context of zero downtime approach. So let's sum up them. So firstly, adding the unique or non-nullable field, like adding a Slack field in our example. And in Sailor, we were facing this problem, for example, when adding expiration date to our order model. Then updating a big number of data. And I can say that in Sailor, we are facing this problem most often, as our clients have quite a big collections of products and orders. And any field normalization, like, for example, recently adding undiscounted price, means that we need to calculate each value separately. Then renaming the field, renaming the created field in our example, but also renaming the table, removing the field or table, or moving the data from one field to another. And all of this operation will cause a similar error like renaming the field. And in Sailor, we face this problem, for example, when changing ID to a universal unique identifier. So the key element is to not removing any fields that previous ORM will use and minimize each migration time. Okay, now, as we know all the problems, I overview the solutions. So the biggest difficulty in changing the version is updating the database, because it's shared resource and we cannot just clone it and replace. To ensure zero downtime, we need to ensure that the updated database will work with the old and the new version of the system. And there are two possible options to achieve that. We can make old code compatible with the new database schema, or we can make the new database schema compatible with the old code. And fixing old code is hard, and it requires to craft 2 releases. So we decided to choose the second path, as it's easier to achieve. And I will describe the solution that fit this statement. And one more important thing is that we are ensuring zero downtime only when switching one version at the time. So in our example, switching from version V1 to V2 will be possible without any downtime, but switching from version V1 to V3 won't be. Okay, so basically the solution is to ensure the transition state with the use of expand and concat pattern, and it can be split into 3 phases. Firstly, in the expand phase, we need to extend the database schema and adduce the code to work with the both database schemas, the old one, the new and the old one. And then in the transition phase, we need to migrate the old data to ensure that we have data only in the new proper format. And then finally, in the concat phase, after ensuring that the old structure is not used anywhere, we can clean up the code and delete unused fields. And as a result, we will get the expected stage. So let's start with the solution for our first problem, which involves adding a unique Slack field. So firstly, we need to, in the expand phase, we need to add a new nullable Slack field. And also, we need to ensure that any newly created instances will have the proper value set on our new column. Then in the transition phase, we need to fulfill existing instances with the proper Slack values. And to minimize the migration time, we will delegate this update to the asynchronized task that will do this in the background. So the task will start after the migration process. And I will tell you more about that later. For now, the most important thing is that the update is done asynchronously. And when the tasks are finished, the Slack column will be filled in with the proper values and will be ready to move to the last phase, that is a contract phase on our version V2. And here we will be ready to safely change the Slack field into unique on our target version. Okay, so the second operation was renaming the created field, and to ensure the compatibility, we have to perform the changes in three main steps that are adding a new field next to existing one. Then we need to copy the data from the old field to the new one, and then finally remove the old field. And on each of these steps, we need to ensure the transition state. And yeah, so let's go into details. Okay, so as before, in the expand phase, we need to add new label new created add column. And we also need to adduce the API. So when any new product is created, it will have proper value set for both columns, the old one and the new one. Then in the transition phase, this time we need to copy the data from the old column to the new one. And as before, we delegate it to the asynchronized task that will do that in the background. And after the task is finished, we can move to the last phase, that is contract phase on our target version V2. So on this version, we need to remove the old field from the ORM and from the code, as we don't want to use it anymore. But we cannot remove it from the database because it's still used by the previous version V1. So instead, we need to ensure that the old created column is nullable or have a default value. So to perform those actions, we need to separate the database and ORM changes. So on the migration on the right, we are removing the old created field from ORM, but not from the code, not from the database, sorry. Instead, we are altering the old created column to make it nullable on the database. And we are also ready to change our new field into our new field created add into non-nullable. So after contract phase in version V2, we'll be in the state when the old created field is not used anywhere in the code, but it's still in the database. So we will need one more extra step to safely get rid of that column. So in the next version, after ensuring that only new field is in use, we are able to safely remove the old created column from the database and to achieve the target state. And as you can see, there is quite lots of steps to just rename the field. Now let's take care of the update of large data sets. So the update should take place in the transition mode, so we can ensure that instances have proper values, and we can safely apply the changes on the target version. And to minimize the migration time, data should be updated asynchronously after the migration process. And here is the example of the migration that calls a task that copied the data from old created to new created add column. And the task is delayed in post-migrate signal. which means it will be called after all migrations are completed to not bother the migration process at any way. So the data will be copied in the background after all database migrations. And now take a look at the task code. I have some tips for you. So firstly, updates should be done in batches. And secondly, ensure that only instances that haven't been updated yet are taken for update. And the instances should be sorted by some unique field like primary key. And in this example, we are taking the products that have empty created at column. And after the batch update, the task should queue itself to not block the asynchronized task queue for too long. And also what's important, the update of instances should be done in a transaction with locked rows to avoid potential deadlocks that might happen when multiple asynchronized task workers are in use. So right now, we know the problematic operations. We know how to write migrations to not crash the system. So the last missing piece is how to proceed with version update. So firstly, we must release the applied changes on expand and transition phases as a patch or minor release. And I will use minor release v11 for simplification. So in our example, on version v11, we will have two new nullable fields, Slack and created at. And next, we need to upgrade firstly to this minor version, that will be our transition state, and then to the target version. So firstly, we need to switch from version v1 to v11, and then from v11 to v2. And upgrade through this version v11 is crucial. So in both cases, the process will look the same, so I will describe it on example from switching from version v1 to v11. So we'll start from the configuration where we have one app instance that is using the database, and we have two asynchronized task workers, for example, salary workers. So the first step is stopping the asynchronized task workers to make sure that they don't process any task during the database migration. And then we need to run the database migration to update database to version v11. And after the migration is finished, we can start the app workers of version v11. So let's notice that at this point, we have app instances of two different versions that are using the same database. But we ensure the compatibility, so when any new product is created on version v1, it will have the null value set for both new columns. And when the product will be created on version v11, it will have the proper value set for both Slack and created at columns, as we had used the API to do that. So then in the next step, we should stop the app workers of the previous version, and finally, at the end, start the salary workers to run the task delegated in the database migrations. So in our examples, tasks in the background will fill in empty values for our new columns. So I described you the zero downtime upgrade. Now let me digress a little what zero in zero downtime really means. So during the update, there is no moment when all app instances are stopped. Instead, the data is upgraded in place while the app instances are still in use. So this may result in minimal downtime, but it's so brief that it's essentially zero and not visible to the user. Okay, so moving back. After upgrade to v11, any new instances will have the proper value set. Old instances will have the null for the start and will be updated by the asynchronized task in the background. So when the tasks are finished, the product table will be filled in with the proper values and will be ready to upgrade to our target version v2. And to do that, we need to perform the same steps as for switching from version v1 to v11. So if you want your upgrade to go smoothly without any maintenance break, remember that the most important thing is to not remove any fields that previous ORM will use. So basically ensure the transition state. And that's it. Thank you. I just wanted to add that here is the link to the Sailor site and also the example project that contains all examples that I used today. So thanks.
Thanks a lot, Ida. We have a lot of questions. If you have some more, please keep them coming in Slido on Room Spaghetti. The first one is, does using GraphQL make the zero downtime migration easier or difficult?
I think it doesn't matter.
All right, next one. Did you ever consider using MongoDB? The questionnaire says this would force the program to be developed in a way that is compatible with any schema version, reducing migration trouble.
We didn't consider it, but I think it's not matter what the database is used here.
Okay. And do you think Django could or should add extra tools to make zero downtime migrations easier or more manageable? And in the same regard, do you have any automations in place to make the migrations easier or more manageable?
I saw recently that there is some package for PostgreSQL that allow to perform this migration, like you are just describing the, I think, JSON, and you are telling what should be changed. So there are some steps to make it easier.
All right. The next question is, what do you think about backwards data migration? Is that something we should take into consideration?
Once again, sorry?
What do you think about backwards data migration? I think it's in terms of rollback, maybe, rolling back the migration?
Yeah, so this solution, like, you need to just make a backup, I guess, before starting this.
Okay. It's always a good practice, I guess, to have a backup anyways. The next question is, what if the expand phase, for example, when you add a column during the expand phase, already takes an unacceptable amount of time, if it's very slow? Does that have any impact on the migration?
The expand phase? No, usually not. Like, it's usually it means that you need to write to one more column. So I think it's not a big deal.
All right. Then the next question is, if Sailor switched to API only, why didn't it change the backend from Django to Fast API, for example? Are you planning on migrating that in the future?
Right now, no, because we are on still growing phase and there is no time for that. But I think maybe in the future.
The next question is, after dropping the old column to reclaim the used disk space, you will at some point need to do a full disk vacuum. How do you handle that without locking the table?
Can
okay, yes, sure.
This one?
Yes.
Okay. It's a tricky one, to be honest. So it's hard to me to answer this one, sorry.
No problem. The next one is, for the column rename problem, there's a moment between the value duplication and the software update. In this period, the new record can be created with the created column. Oh, I should have read this before. I'm not sure. Maybe you care to clarify, whoever asked the question? Was it you? Yeah, then, I mean, maybe you can.
Okay.
Yeah. When you duplicate the value of the created column, and you update the software in order to read and use the new one, maybe there is a period of time that the old software create maybe new records with the created column values. So after the software migration, do you copy this old value to the new column?
Like, there's maybe, I will move back a little. So here, in this moment, yes, when you are version v1, it will create like new instance with value set only on old column. The new will be empty. So right now, nothing's changed. Then when I'm stopping the API instance of v1, so in the database there will be values, like the column will look like that at this moment, and the task, the celery task, will fill in those values. So right now, there will be no moment that I will get new rows with empty slack and created add columns. It's the state that I will be updated in the background. And right now, when any new product will be created, the values will be properly set on both columns.
Great. There's another question about linting. Do you have any linters that run on the migration files to ensure that you're actually following the process that you presented?
I think that the easier way is just to run some SQL statement to check if how many empty columns, for example, do you have. So it will show.
And do you have a recommendation to monitor any of the background tasks you're running? So basically to know when you're done with the migration?
No, because I'm not working on this part of the project. I'm just responsible for creating this, for ensuring that the code is prepared for that. But I think you just need to check the celery queue or another asynchronous task queue to ensure that it's finished.
Okay, there's some other mention here in the comments that the SQL migrate command can also help to spot cryptic behaviors in the fields default, creating a migration operation that backfills at the rows. I don't know what that comment is like. Is that a question actually behind that? Maybe the question taker would like to clarify that. Okay, then feel free. No matter what. Then let's continue with the next one. How about renaming tables when you do migrations? Is it also possible in zero downtime?
Yes.
Okay. Can you maybe explain how it works a bit?
I will have to think about that. I think it's not like this short, because we didn't do that, to be honest. But we can stay after and maybe discuss it, because it's hard for now to.
Sure. This is a longer slot, so we have some time after this talk before the next talk start in the other room anyways. So then we have two more questions, I think. One of them is, do you test the migration on some test database before actually running it on production, or do you just fire it at production right away?
Again, I'm not responsible for doing that, but when I'm implementing the changes, I'm always checking it on the local machine. But yes, when it's on production, I know that the team that was responsible for that was doing the test, right?
All right, then thanks, Iga.
Thank you.
All right. Next up, we have William Arias. He is a senior developer and evangelist and data scientist at GitLab, and he's here to tell us about handling technical debt in machine learning code bases. As always, questions are welcome via Slido on the Spaghetti Room. Now, give a big hand for William, please.
Hello, thank you so much for being here. It's Saturday. You must really like this topic to be here on Saturday. Yeah, hearing to some stranger. So yeah, my name is William. I am a developer advocate. We recently changed the name. We don't like anymore the other one. And data scientist at GitLab. So today I want to make a quick disclaimer. One of the things that I will be sharing today is basically my learnings as a hobbyist, entrepreneur, consultant, data scientist, and all the things that I have been doing since 2017 that in the realm of machine learning. So I don't mean to tell you this is the ultimate solution, this is what works, and the rest of the things. No, this is what I have learned from experience in the field. And so it's very opinionated. And one of the things that I want to highlight is that there are use cases that might apply or not to whatever you are doing that involves MLOps. And also, I am in that process of realizing that I am getting old. And as a millennial getting old, you start thinking, oh, I should have started saving for retirement. Maybe I should invest more. So that's why I said there are lots of things that you have to pay in life. And one of the things I've been paying recently, but gladly, that's a debt that I am happy to pay, is the technical debt of machine learning applications, because there is a lot of glue code working with this. So that's the inspiration for this. I will frame it in these three questions that I like to ask to myself before doing something, which is, why are we doing this? How am I going to do it? And what am I going to use? So this also helps you to break down if what I'm doing or what I'm sharing will apply to your use case, or even the what, if the technology that I am using is something that you can use, because there are regulations that this is one of the things that I've been finding the most in this field, that it's very cool to see those applications, demos and everything, but now try to put it in a bank, try to put it in anywhere where there is regulation. That's a completely different story. Even just getting the data to start. I had to go recently through a 3-month process of clearance to get access to some data that I needed to use to learn something, because legal had to do something that I didn't want to pay attention what was it. I just wanted, okay, let me know when I can do this, and then I will load the data set. But yeah, just to saying the different things. So another thing that I have learned is that as technologists, we all like to automate things, and we like to say, let's make this thing automated and let's do it like super fast. But sometimes before you do that, you should question what is the actual process and why do I want to improve it? And in this case, one of the reasons, the why behind this is because in machine learning, especially if you have been doing it for longer, these days it's more abstract, there are a lot of manual steps that you have to do. Therefore, there are many points of failure and tweaks and many things that you have to do. And just yesterday, one of the presentations that I was attending was about the AI Regulation Act, and the speaker was telling me that sometimes they said that this was from our conversation, that in Europe with all these regulations we are tampering innovation. But one of the takeaways is that, but maybe if we follow this regulation, we will bring more structure to the experimentations in data science, and eventually the outcome of what we produce will be more useful, because he was showing that there are many research that is useless because they don't follow good practices. Therefore, there is data leakage and more things. So there is a big reason, for me at least, as complementing from what I learned yesterday, of why should I automate many things and I start paying that debt. And where is the main inspiration? So my background is in machine learning, and back in 2017, I was working with chatbots before it was trendy. We were building different customer support chatbots, and I am from Colombia, but I live in the Czech Republic. And it was very interesting because the chatbot had to understand Czech, and I don't speak Czech. I've been trying to learn. And the beauty of what we do is that you can apply layers of abstraction. And I was able to build a chatbot that understands Czech without speaking Czech, because all I care was give me words and I will convert it into embeddings, because not even the computer sees words, they just see numbers. And I am going to judge the intent or whatever classification based on some number and metric, not not other things. But back then, those chatbots were more simple. But here, when we were working on this, we were doing what is called conversation-driven development. So we were immediately putting something out there in production. Then someone was asking something a different way, and we realized that the chatbot was failing, so we had to retrain the model using real data that the customers were putting into the chatbot. And when you do something manually different times, many times, you might start wondering, there must be an easier way to do this. And I was almost alone doing this thing, and as I said, my background in machine learning, I said, maybe I should start exploring something else. And then back then when Google had fewer ads, I started Googling, and then I came with it to the term of DevOps. There is something called DevOps. Apparently, software engineers, they have solved all of these things that for the machine learning or data scientist realm, this is not trivial. This is not something that, yeah, we all know unit testing. No, this is not like that. So the inspiration came that every time that there was a new intent, we had to retrain the model, and that involved lots of manual steps. So I said, I don't want to do that. There must be an easier way. Also, this is very famous, tracking experiments. What we were doing was duplicating the Jupyter notebook, extracting values and putting them on Excel or something like that. And this thing eventually, if it's painful when you are a solo developer, now imagine when you have to do this at a scale in a company with more people doing the same. So here, this becomes a problem that you say, okay, this is intractable, I need to do something. So in that something, the goal is that what I propose is that we don't necessarily say, let's automate many things and replace part of the job of a data scientist. No, what I wanted to do is how can we augment the data scientist workflow? So we start paying in little chunks, start investing now. I've been learning about investment these days. So there is some compound interest at the end of the day, and we start paying that technical debt of the machine learning systems gradually. And at the end of the day, augmenting the data scientist workflow. So there is one thing in life that they say that brings happiness, and it's when you choose the problems that you want to solve. If I impose you a problem, you might not be quite happy with that. But if you say, this is the problem that I want to solve, you have this intrinsic motivation to do it. So I said, these are the 3 problems that I want to solve. I want to reduce the manual steps. I want to have quicker experimentation. We need to share models easier with other data scientists, and I want to incorporate code and metrics review in my workflow. So I start talking about developer workflow, something that software engineers have been familiar since they start in university, I will say. Back then and today, this was already a thing, being GPU poor, that you need to train something and you don't have specialized hardware. And if you have it, can you raise your hand how many of you have tried to configure a machine with NVIDIA drivers and succeeded the first time? Well, yeah, it's very hard. And the third is that you need to train and retrain the model quickly, and if possible, in an automated fashion. So those were the 3 problems. Fast forward, many scars, many problems, many reality checks. This was one of the architecture that became a blueprint for the things that I was doing back then in 2017 to 2019, which was discovering open source packages such as DVC, learning Git. Now I work at GitLab, so now you can see how I ended up in GitLab. I didn't know Git back then. Then learning Git and saying, okay, this is some sort of blueprint in which there are 2 things. Git wasn't created for tracking data, only text files, the code. So we need DVC to track for data version control. The concept of having a project, a remote repository, automating the training and testing. So here, if you see this step of build, train, and test, the one in the middle train, is different because there is also the concept that if when I'm using CI or continuous integration, another concept that has been battle tested and is old, I say, okay, so I can automate that. I will read the data from the data registry that DVC allows me to register, and I will just pull that data, download it in that machine, and that machine is enabled already with a GPU because I am using a SAS GPU that I can automatically allocate by using CI, and this will extract the data, execute my scripts, and train the model, and then use that model as a regular artifact that gets created in a CI automation. And then testing the model. So this was very interesting because in software engineering, if the unit test pass or fail, then you say, good, this will work or not. In machine learning, probably you know this, but the script could be correct, everything can pass, but the model can be biased, can be a bad model, the performance can be bad. So what do we do here? So we need also to automate how can we collaborate around that testing and reviewing not only the code, because to be honest, in data scientists, the other day I was in a party and one guy was asking me, what do you do? And I said, sometimes data science. And he said, that's not real programming. And I was like, okay, that's when I understand why he said that, because many of us work on Jupyter Notebook and you don't necessarily have that strict workflow that you have to follow. But if we don't do something in a certain way, the cost of the problem can be very expensive. So that's one thing to take into account. And then I said, I don't want to do this thing manually, so I want this machine provision for me automatically. And then this is what I was saying about choosing the problem. Sometimes when you see the light at the end of the tunnel, you think that you are coming to a solution, but might be another train that is coming to hit you. When I was doing this thing, then I came to this word of Kubernetes. I was like, okay, what is this thing? Because it looks like it can serve for my purpose. So at this point, I found how Kubernetes can be very helpful when I'm working machine learning applications, because the test can be successful, but you need to try the application. What we have been seeing, have you seen what has happened these days when they deploy these applications and they apparently work, but when people are using them, they start giving results that are really bad? That type of manual testing, that type of users interacting with it, then I found that we can use then more technology that we will deploy the model to some ephemeral environment. People can use it, and people can say, yes, this passes or not the test. And if I click yes, it will continue moving forward in the CD pipeline to eventually make it to a production environment. And automatic deployment if you feel adventurous, or you can add manual steps for this deployment. Fast forward now, when I came to my team in my current job, we had more data, and we said we need to use machine learning to learn from how our users are using the product and what can we do to improve the experience. And then this was what I found in 2023. Like, yeah, sure, you want to do all of that and automate it? Just, this is all you have to learn. So now imagine that what I see is that every year there are more things and more hype, more technologies, more things that they are telling you, this is what you need to do this. And then what we say is that I've been an architect, and when I was architect, I remember vendors coming and saying, look, you have to buy this, and then all your problems will be solved. And when you already have an architecture that is working, the golden rule is, if it works, don't touch it. So I don't really want to add a new component just to solve that little problem. So what can we do? We can say, start small. Sometimes it's not a decision. They were saying, no, we are not going to buy anything. You have to automate all these things, and you have to worry what you have. Okay, so so how can we start? So let's start building with what we have, and gradually. So this sounds okay, but then I also realized that these very same problems that I had when I was just working in smaller projects, they come back again, but in another size, other dimension, when you are in a bigger team. And by dimension, I mean that it's also, all these problems are multiplied by the number of data scientists in your team. So everything with this thing that they said that when things are bad, they can get worse. I saw it here growing. So I said, okay, these are the same problems that we were facing, but I will say that here, the one that is stealing all the show is that we need to improve and have better collaboration. And this better collaboration implies that we need to start doing small investments, to the topic of this conversation, to enjoy compound interest. And this is what we have been doing. We said, let's start small with what we have, meaning DevOps practices and things that are tested with the software engineering or developer workflows, and let's put them into practice in something that we already know how it works. So here, this is a screenshot of something that also yesterday I liked something that in some presentation, I don't remember, I think it was the keynote, that they were saying that you have to always think, and this is something that we usually don't do, as technologists, the experience of the end user. So when I came to this team, I had the machine learning experience, but also data science experience, but also I was learning DevOps already before the rest of my colleagues. And many of my colleagues, they live and they love working on Jupyter Notebook. This is very hard to tell to a data scientist, stop doing that, you have to refactor your code and make it production ready, and then you can put your model in production. If you don't do that, you can't then, that will never going to happen if you tell them that. So because I had that empathy, because I also like Jupyter Notebook, but I also understand the importance of refactoring the code and putting it in a production-ready script, I said, let's automate, let's use a staging environment, as you see here, and use your Jupyter notebook. You don't have to refactor. You have to make sure that it runs. And the only thing I'm asking you is that we are going to use a standard with a directory, the structure of the directory. And all you have to do is that make sure that in the commit message, you write train, because we want to train a model, and you give me the name of the Jupyter notebook file. Just do that for me. So you can still use your Jupyter notebook, but if you do this, there was a rule in the CI that was going to say if a simple regex, if it's a Jupyter notebook and it has this train, it was going to take it and convert it to a script and use GPU. So this we did, and here we start solving at the scale of more people the manual steps. What was the other problem? That when there was a new data scientist and you have to onboard them, everyone brings their own conda and practices and dependencies. We said, no, you have to, in the part of the CI, you will pull an image, that is the image that we are maintaining with all the dependencies that we need, and then you will train following the template that we have for Jupyter Notebook, using this thing in this model with GPU, and then we will notify and generate some metrics in the merge request. So how does this look like? I had here some examples, but I wanted to show you how it looks like. So imagine that I am a data scientist new in the team, and someone tell me that I have to train the model. So here is when things start getting interesting, because we start learning things from software engineering that for many data scientists, this is like discovering fire, including myself. So let's say that if you say, okay, I have to retrain the model, and I have to do whatever, I don't know, change some hyperparameter or something. So here I can use, just for the sake of the illustration, I'm gonna use a web IDE, and I'm gonna just add a space just to show you what is important about this. So here, in this one, but let me actually show you a better example. You see here we have the notebooks, and we have the train example. So this is what a data scientist will be doing, and this is what they will need to work on. This is what they will need to commit to the repository. So let's say that as a data scientist, you say, okay, now I want to change this from 0 to 5 for whatever reason, because I'm tweaking things. And then here, I have to put the commit message, as I was telling you, and the path. So I am struggling here with one hand writing this thing. Did I put it correctly? Yes. Training example. One second. Yesterday there was one guy that he was showing different layouts of keywords. I just remember Jupyter Notebook. So look, this is all that I'm asking the data scientists to do. So then when you go to the MAR, you see that here automatically what is happening. The training is running, and there will be a notification. And this notification, whatever metrics we are training and publishing on artifacts, they will be published here into the MR. And if I open this training stage, you see that it activated a job that is called train commit. And one of the things that is happening is that it's automatically allocating for me a machine that has GPU enabled. So all of this thing that is happening now is training a model that needs GPU automatically. So as a data scientist, what do you think is the main advantage that I have with this? That I don't have to worry about infrastructure. Someone else will automate this for me. And if that someone else is someone that also understands the machine learning process, they will know how to make it easier for me to start focusing on the modeling or data processing or things that are more relevant for a data scientist. So here, this is an automated job, and this will be the experience that someone will have. The difference that I use here a web IDE, but you can do it from your Jupyter instance. One of the most rewarding things is that another colleague, that his background is statistics, he later discovered that we have something called scheduled pipelines. So he said, we don't have to do this. If we want to check model drifting, we can just schedule a pipeline that will run every week or every month, and it will automatically publish the results. So this is how we also start automating the training and retraining of a model and checking if there was a model drift. I already showed you how we could automatically allocate GPU, and I am rushing a bit because I already saw a time alert. And I wanted to show you some different use cases, which this is what I meant, that there are the different scenarios where I have found this useful. So the experimentation one in data science is the one that I just showed you here. The job just finished. And this is the one where you as a data scientist, you want to quickly do things, train a model, and just push, git commit, git push, and send it to a remote, and use this all automatic allocation of hardware and so on. There is another one that is when things start getting more interesting. That is, let's say that you are working with different things that are more trendy today. You are, I don't know, training what embeddings and doing some other things. Here you see that this is a model that is more complex, but the things are similar. You have to build an image, you have to test it, you have to train a model, and in this case, what I'm training is what embeddings. And then you have to review the model. And taking advantage of that integration with cloud-native technologies, one of the things that I was doing is that, if you see here, this is an environment that is ephemeral. This is one integration automated with a Kubernetes cluster that when the pipeline gets to this stage and you click here in View App, it will spin up this ephemeral environment, and here is where people, if they do this more often, they can try different inputs to the model because the unit test it passes. But here I can try, okay, like what you have seen these days, people, the prompt injections and all those things. Here is the stage where by using this, you can catch those errors that they don't appear when you are doing only unit testing. And then similar notification. And here you can see that this is what should appear in the other one. As a data scientist, one of the things that usually slows us down, and that I have seen it in companies of all sizes, is that you say, how is the model performing? And you say, I'm going to send you the Jupyter notebook. And then you send an attachment, and you have to guess what are the dependencies, load the Jupyter notebook, sometimes just to be able to replicate the experiments. And that thing usually doesn't work. Here, you don't have to open code. You just see the results here. And if one of these things doesn't fit whatever you need, so you say, no, I don't accept this. And this doesn't get merged into the code base. And one of the cool things that we have been doing recently, as you see here, is that there is an integration with MLflow. So now every time that we run a job using CI, this job gets logged into something. This is MLflow in the backend, in the model experiments. And now I can see all of the different experiments that I have been running. So you see that 46 minutes ago, I was trying something here. So if I click here, you see that it says that, okay, I ran this job, this is the performance of the model, and this job generated certain artifacts, and if I click here in artifact, you see this is the model with the embeddings that was trained. So as you can see, this is one of the things that now, if I want to collaborate with other people and I say, use my model, they can see all the code that generated it, the artifact that was generated. And now it's not me, but it's someone else that say, I need you. This is what I have seen mostly with the real life customers, and that they said, we are highly regulated, and every prediction that we make, we have to show the code that created this and who approved this change or not. So here, by standing in the shoulder of giants, and by that I mean DevOps, all of these things were solved already. So there is already auditing purposes. There is already this concept of SBOM, the software bill of materials, that we can just tap into that and say, now we can use this for machine learning. Recently, I saw that one of the customers that I was consulting, they changed it. They don't call it SBOM, but MBOM. This is model bill of materials. And how can I do that? And I say, yeah, sure, we can do that already because software engineer already solved it for us. So this machine learning app, the one I show you, and this is another one that I find, how 2 minutes? Is that you probably are familiar with cloud providers that they tell you that they already have a service that it creates an endpoint for you, and that endpoint will serve your model. If you see that, that's completely true. There are many other tools that can do that. But these tools, they don't necessarily have this tight integration with version control. So one of the other experiments or use cases that I have found is that, example, if you are using something like Vertex AI or SageMaker from this other vendor, you can still use DevOps to be the one that orchestrates the vendor. So in this pipeline that you see here, I am not training using my own infrastructure, Kubernetes, but what I'm doing is using CI and CI principles to orchestrate the interaction between my code and data and that provider. So here I am calling the API, and I am training a model using the infrastructure from that cloud provider. And at the end of the day, if in the same fashion, if you want to have that traceability of when this model was created, what was the dependencies and image that use it, you see that from here we have that visibility to say from this pipeline, that model in that cloud provider was trained automatically. So this is one of those things that I've been working on as well. How can we make use of those other technologies and integrate them, because there are different use cases for all flavors and all different requirements. So one of the things is that by using open source and DevOps practices, we have solved problems of how we can collaborate easier by having this display that is friendly for a data scientist or machine engineer. We can have that traceability of the artifacts and dependencies. And recently we are testing another thing in MLOps that is called the model registry, which is, again, taking concepts from software engineering and saying, this artifact that was created, how can I promote it through different environments? I have it in QA, I want it in pre-prod, now I want it in production. We also want to try, and we will try canary deployments. Are you familiar with the concept of canary deployments? So we want to do the same, but with a model, serving traffic at different pods and testing how it is going, and if it's all good, so we just release the full application in the production environment. So as you see, I've been having a lot of fun learning DevOps as a background in data science and machine learning. And I keep seeing that we are just discovering each other and having that empathy of understanding the data science workflow and seeing the value that it brings to adopt DevOps practices. We, at the end of the day, can make our life easier. That was my main motivation when I was working before. And this is one of the architectures that we have running right now in production. This is taking a lot of data, building, retraining. And as you can see here, we are pulling automatically from Snowflake using Python SDKs and saying GitLab runner. So from here, read, now pass it through all this pipeline, and then a merge request that if whatever model, the performance is working or not, we merge it or not to production. So all of these things is boosting our productivity, making our life easier, because we don't care about GPUs, not having GPUs in this, or not being able to, not having the NVIDIA. We are just using SAS runners automatically allocated here. And putting all together, I wanted to say that beware when someone tells you that all you need is this, that with this platform you solve all the problems. There are no shortcuts for all these things. My recommendation is that you start small with what you have. Putting it, again, what I was saying with the technical debt, is start doing those little things. There are lots of things that people already know, and you can use that transfer learning to slowly start adapting and adopting those workflows into the developer workflows, into machine learning workflows. And one of the things that we have been learning recently from experience is that there is no MLOps without DevSecOps, because I just mentioned auditing, and I didn't even scratch the surface when it comes to security in the code. We have been seeing how, you don't imagine if you pass a SAST scanner on a Jupyter notebook, all the warnings and different security vulnerabilities that it finds. So that's another step. I also didn't touch into monitoring, which is another challenge. But I am confident that we will continue moving towards how can we use and sit on these DevSecOps practices to end up building a more robust MLOps practice in our team, because we are starting small with what we know and having a very, 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 very small and soft transition that has in between, has as a center the data scientist and what we need to, at the end of the day, deliver results. So thank you so much, and I am open for questions, and I will spend the rest of the day here if you want to chat more.
Thank you so much, William. We have a couple of questions on Slido. The first one is, how dangerous is it to rely on Jupyter Notebook? Can it be that the training result on the notebook trained remotely is different than the one you get locally?
Yeah, that's totally. But this is the beauty of this. Like, it can be very dangerous. I'm not gonna lie. But if you have it here, like in this pipeline, and you see the results, at least in this pipeline, you catch something, you don't let it pass to production. So you catch it earlier. That's one thing. And with this that I was showing, by using these cloud-native components, you are reducing the likelihood that the thing that you are seeing in testing will be the closest as possible to production. It's not perfect, but it's better than just relying on the results that you get in your notebook or in your local machine.
Then another question is it not easier to educate the data scientists rather than building around some bad habits you might have?
Yeah, try. we tried that. We tried that, and yes, but you know, this is about yesterday in the keynote. That keynote was really touching. Someone was saying that when they were the educators, like how you empower people, And how do you teach something? I have seen it. I have seen that they say, no, if you want this, you have to refactor. And that usually will not fly. You are dealing with people. People have emotions. But if you say these things that are little tweaks, you still stay a little bit in your comfort zone, but it slowly move. The success story with this is that the data scientists in the different teams that I belong, they start expressing interest, they see the value, so I don't have to sell anything, I don't have to impose anything, they just see the value saying, if we adopt this, this is actually making my life easier. So that's how I am, not me, that is how learning this is, that education is happening, but not the one that is imposed to do this. And to be honest, I always like to remember some manager that I had. This is not like we are doing open heart surgery here. The people will die if we fail. Most of these models, many of them are batch processing and bulk predictions. I mean, if it fails, okay, we catch it here. The cost of the problem is something that you need to consider. Once I was working with the police, and they were saying, half an hour of this and we cannot process some criminal. So that is a very costly problem. That you don't want to fool around. But these things where we are running predictions of historical data, is the cost of the problem versus let's start paying this debt slowly. Yeah, I always think like that in what is the cost of the problem, what are we trying to solve? But that is an excellent question, and I will say that question goes beyond the realm of technical experience. It's most how is it dealing with people, which I'm not qualified to go deeper in there.
Thanks a lot, William.
Thank you.
Hello, everyone. Thanks for coming. We have here Bryce Beagle. He flew from California to here to grace all of you with his blessed presence. And he's also going to talk about importing machinery. So there you go.
All right, welcome everyone. Show of hands, who here knows how to import a Python module without using the import built-in? All right, a decent number. Well, we're gonna finish the talk really quickly because that's how you do it. You just use, or you don't use the import keyword, you use the import built-in. Done, okay, talk's over. We can all go home, woo! All right, so really the title of the talk is a ruse. I'm going to be talking about like the internals of the import library and how it works behind the scenes. And you can take from that how to import without using the imports keyword. But really, we're going to go over what happens behind the scenes when you run from X import Y. And I only have 30 minutes, or 25 because of Q&A, so I'm going to go really fast. So just as a little bit of background information, I work in the San Francisco Bay Area as a developer infrastructure engineer at a company which requested that I don't say who they are. So I work on like package and language versioning, static analysis tools, and linting, and basal build systems. And then I have a GitHub account, Bryce Beagle, just my name, and then my Twitter is Ignoremes, where I don't typically post about software engineering stuff. It's really me talking about bicycle and pedestrian infrastructure and hating on cars. So if you're into that kind of thing, go there. First of all, what are modules? At runtime, modules are really just objects, instances of the module type. There's really nothing special about them once they're in your namespace. They can be passed around by reference. They have dunderdicks with their own internal namespaces. You can access attributes on them using the x.y syntax, and those attributes can be either just variables or methods or other classes. So modules can come from PY files, and that's how you're typically used to seeing them. You import from a package or a module, and it's really just a source PY file on your file system. But they don't have to come from source files. They can come from compiled binaries, like in this case, polars, which is implemented in Rust behind the scenes. It actually, when you import it, it's coming from a shared object file, or on Linux and on Windows, it's going to be a DLL file. Modules can be packages. So all packages are modules, but not all modules are packages. Here we have like the sys built-in. It's just a built-in module. We got a 6, which comes from a PY file, like I said before. Click also comes, it's a package here. It's not coming from a click.py. It's coming from an int.py and a click directory, so that's why it's a package. And then poetry is a special kind of package where it's a namespace package where it's kind of implemented across multiple different directories and kind of merged together at runtime, but we're not going to go into that. But there's just a whole bunch of types of modules and a bunch of types of packages, but for the sake of importing, they're all the same. Well, not like the implementation, but like once you are using them, they're all the same. So modules are global singletons. You import it once, you can modify its namespace, and you import it again, and it's going to be modified elsewhere. It's an object that you can access from anywhere as a singleton, basically. So if you've ever done any, modules are also cached. When you import a module once, the next time you import it, it's going to be reused. It's coming from a sys.modules dictionary, and if you pop from the dictionary, you can kind of force it to re-import it the next time you use the import keyword. And then there's inside the import lib is a dedicated reload function, which you should use instead of touching the sys.modules cache. In summary, modules are just dynamically loaded, highly reusable objects, accessible throughout a code base. They're just objects that you can access easily. And now that we've learned what modules are, we can kind of move on to the more interesting question. Like, how does the interpreter find them, and how does it load them into the runtime? Like, how are modules? So the steps of importing, sorry, let me make my speaker notes a bit bigger. I'm having to look at my slides more than I should. Okay, what does importing do? First, the package needs to be found, then it needs to be loaded into the interpreter, and then the package or module needs to be bound to the namespace in which it's imported to. So the overall hierarchy is you take your just normal from X import Y, the import keyword is used. That calls the import dunder that I talked about at the very beginning of the presentation. And that invokes a finder object. And that finder is responsible for going to find where the source file is located. And then returns what's called a module spec. That module spec is then fed into a loader. That loader then loads the module. And that gets passed back all the way up the chain. And the import keyword is responsible for binding the result to the namespace that imported it, or whichever namespace it's going to be imported into. So if you just use the import keyword, or import built-in, that final step of binding it to the namespace does not happen. You just, the function returns an object, but it's not going to exist, it's not going to be assigned to a variable for you to use. And that's what the keyword is responsible for, among other things. So yeah, as I said, the import keyword calls import, figures out which attribute needs to be retrieved from the thing that's being imported. So if you do like import collections.abc, you need to bind collections and ABC. You need to bind ABC to collections and then collections to the importing namespace. There's just a couple other examples. Okay. Sorry. Okay. So, sorry, I'm really nervous. What was I going to say? All right, as I said, the import built-in is called by the import keyword. It invokes the finders and loaders. It does not bind a result to a variable. And you're not really supposed to use the import import built-in function to import things dynamically. The import lib module has an import module function that you should be using instead, and it manages caches a bit better. It manages there's some invariance that the import machinery relies on, where it expects the keyword or it expects some state to be set outside of the import built-in that the import module function does. And so you shouldn't really be using the double underscore import method on your own. You should be using this provided function. So loaders. Loaders are just abstract methods, and there's some that exist in the standard library implemented by default. And all they need to define is a create module and an exec module. Sorry, wait. I skipped a slide. Finders. Okay, so first, to find the module, you need to have a finder object. The finder object needs to implement a find spec method, and that method is called by the import, the double underscore import method, to figure out where to find the package. So it's given the from X import Y path. So it's going to ask for X and it's going to ask for Y. It's like, where can I find X? And if Y is a package, it's going to ask for where to find Y, or a module, it's going to ask where to find Y. So this find spec method on the finder object needs to return a module spec that just declares, here's where I found this, and here's the loader that I'm going to have the interpreter use to load the package, or load the module into the interpreter. So here we have the built-in importer, where you ask to find the spec of sys. And it returns the built-in importer loader, and that loader will then take the spec and bring the sys module it'll load the sys module. Okay, loaders, they need to define two methods, a create module method and an exec module method. The create module method is responsible for creating the module instance object. By default, you don't need to implement this. Most implementations just return none, and then that just tells the import machinery, just do your default thing, make me an empty module and populate it. And then the exec module is actually responsible for taking the file that it found, or the SO, or however it's getting the module, and shoving all the things into its dict attribute. So this is how if it's a source file, it basically execs the file and takes the the contents of that file and puts it into the dictionary of the module. And then there's one other keyword, and that's importers. Importers just define, or they implement both the finder and loader abstract base classes. And when the find spec just ends up returning self as a loader, so that the import machinery is just like, okay, use me for both the finder and the loader. And those are how most of the built-in importers or built-in finders and loaders are implemented. Okay, namespace binding. Once the module has been found and loaded, it needs to be bound to the namespace where it's going to be used. So in this case, when we import numpy as MP, the import statement needs to first load the numpy module and then bind the result to an NP variable. So it's not going to be bound to the name of the module. It's going to be bound to the argument provided to the keyword. Note that using the _ import method does not bind to the namespace. And then if you do import x.y or logging.config, it needs to bind both logging to the outer namespace and then config to the inner namespace. So it's got to do multiple binding operations. Submodules are not implicitly loaded or bound to the namespace. And so in this case, logging has a config submodule, and it doesn't exist in the logging namespace because we didn't ask for it. But other modules can exist in the namespace because they are imported within the file. So when logging is imported, its init.py is executed, and it imports traceback. And so that implicitly gets put into the logging.traceback namespace. That's only because the init.py of logging executed that import. But because logging.py is init module or init file does not import config, it ends up not being in the namespace. So you have to explicitly import, another slide there. You have to explicitly import config to have it accessible. Okay, where are modules? The default place that people refer to when they talk about importing modules and figuring out where they're going to come from is sys.path. And sys.path is used by one of the finders that's in the the sys.path used by one of the finders that exists in the standard library to figure out where to find source files specifically. And so if you look at it, it's got the directories. So my IDE puts some directories in there. It's got the standard library directories. It's got site packages from my distribution. It's got some other things from IDE. It's just these are all the places that one of the pathfinder will look for source files to import. But there's also sys.metapath, which is a list of finders or importers, because sometimes they do with loading and finding, a list of finders to figure out where to. It takes the name of the package and then needs to figure out how to So first, the interpreter or the import method will iterate through sys.metapath, asking each of these finders, hey, can you handle this name of the package? And if one of those finders says, yes, I can handle it, then it's referred to a loader. If it gets to the pathfinder, because the first three cannot deal with it, then the pathfinder object implementation iterates through sys.path and looks for source files. But before it gets that far, it first imports from like a virtual environment finder that's loaded by like PyEnv or virtualenv. But then it goes to the built-in importer. So if you're trying to load sys or math or any of the other built-in packages, they are handled by the built-in importer, and it will never even check sys.path for a package called sys or a package called math. It's handled already by the built-in importer. And then finally, sys.pathhooks is also used by the pathfinder finder. It's a place where you register file extensions to be imported or to be found and loaded by specific importers. So in this case, sys.pathhooks has a zip importer finder or importer, and then a file finder. So if we go back to the sys.path, you'll notice on line 5 here, there is a 312.zip file path in my sys.path. That file doesn't actually exist on my machine, but the interpreter is set up to check there for a zip file that contains source files. And that is handled by the zip importer, finder, and loader. And then after that, it checks for .py files in the file finder. And this path hooks is actually a list of callables. So in this case, it's a callable class or a function that it checks the file path and then, it checks the file path and then says, yes, I can handle .py files, or yes, I can handle .zip files. Okay, now we're going to go a bit in depth with some examples to go over what I'm talking about here. And they're going to get more and more complicated. So this is, imagine this, we have this package here with an init.py that prints its origin. So the double underscore spec is some magic attribute that's set by the import system. And the origin attribute on that is just where the import machinery found the module to be loaded. So for source file, it's going to be a string just holding a dot, like the path to the .py file. For shared object files, it's going to be a path to the .so file. So that's going to be printed when the file is imported, because remember, when you import a file, it's executed. Then it's also got a class with some attribute on it. So really just two things. It prints that import time, and then it's got some attributes. And I'm going to keep this example around for a couple slides, and then it's going to disappear because I'm going to run out of room. Okay, so here we have just a normal directory that I've appended to my sys.path. It contains source files. Because we use the path finder, or because the path finder exists in the sys.meta path, it's going to be checked for a package called, well, it's going to be, this is called what, is what I've named my package. Can't find it first, I append it to the sys.path, then it can import from it. It prints, hey, I was imported from here at import time, and then I can access some attributes on the class. Nothing special there. That's pretty typical of what you're used to, other than I just manually put it in my path. Then we can import from zip files using the default import machinery because of that zip importer that I talked about earlier. So I put a zip file that contains my module, my package here, on my sys.path, and then import it, and I can see that the loader for my package was the zip importer. All right, we can do this manually too. We can bypass the zip importer, finder, and loaders, and implement them ourselves. And I understand this is a lot of text and hard to follow. I did my best to cram it onto one slide, but splitting it up probably was worse. All right, so we have a zip finder. It implements find spec, and it's given the full name to the thing that's being imported. So in this case, it's going to be the string what. Then it, well, here's how it's going to be. I'm going to show how it's used first. So I append a zip to my, nope, okay, going back. All right, so, okay. Find spec takes the string that's going to be imported, then it checks everything in my sys.path, because this find spec is used. It's. Sorry, wait. I did something wrong here. All right, I have confused myself. Sorry about this. What did I do? Okay. Yes, first. Okay. Sorry. Okay. We make a path hook that refers to the zip finder that I just showed on the other slide. I'm going to go back to it. So we put in the path hook a function that accepts a path and returns, if it can handle it, it returns a zip finder. And I instantiate it with a single instance attribute of path. Then we use, so it's got a class attribute or an instance attribute on line 7. Then because we've said we can handle this path, we are given the package name to import, and we check, okay, does a what in a .py exist or a what.py exist? And if one of those exists, then we return a spec that refers to the zip loader. There's a bunch of other stuff here that's important, but not for, I'm going to gloss over it because I'm running out of time. Okay, so zip loader is returned by the zip finder. That zip loader implements create module and exec module. Create module returns none because it's just going to defer to the default module object creation, and then it populates it by loading the file from the zip file and then execing the contents into the dictionary of the module that we just created. All right, and then so the path hook I talked about before, we append it to sys.pathhooks as a class method. and then we can import from the zip file that exists in sys.path. All right, next we can talk about importing from GitHub repos. So at import time, it's going to go check GitHub. Does this file exist for this package? And then download it and import it. So again, we implement a finder. We register it with a GitHub repository string, and then put it in the sys.metapath. So it checks the full name that's passed into find spec. Does this exist in the GitHub CDN? I have omitted that implementation. Well, yeah, I omitted that from my slide because it was getting too noisy. But it checks, does this file exist on GitHub? And if it does, then it downloads it, puts it into a temp file, and refers to the source. It uses the built-in source file loader because it's just a file on disk, and you can use the default loader that's saying, okay, here I downloaded the file to this downloaded file path. Please load it from there, and then it execs the file into the namespace. All right, so GitHub Finder puts on the sys.metapath. Oh, and you can see that at import time, it prints out the CDN URL for the path. All right, okay. Now, final example, we're going to import from Rust at import time. So in this case, we're going to register a GitHub Rust finder with a package that I'm saying. So I'm saying for any package named what, check this Git repository for it and try to download it, build the Rust into a Python package, and then try importing it. So we make a find spec. We implement a finder with find spec that clones the repo, not showing the implementation, builds the repo using cargo build, and then once it's built, it uses the extension file loader, also built into the interpreter, and then it tries to load the package from the path to the SO file. And that ends up just working. We can, using some magic. And so here we append it to the metapath. From what import foobar, and you can see it clones it and starts compiling my Rust package at import time. And then we can use the attributes on it and see that the origin of the import, or the module, is libwhat.so that was built from Rust. There's actually an example where this is useful. If you're familiar with Py03 or Maturin, there's a Maturin import hook where if you're developing Rust bindings, you can, instead of going cargo build, Python run, cargo build, Python run, you can just add the import hook so that it always builds the cargo crate, the cargo crate at runtime. But you wouldn't really use this in production. It's just a development feature, and you would probably never import from the Git repository. You'd just do the cargo building part. Things I have skipped over: relative imports, submodules and subpackages, namespace packages, dynamic runtime created modules, things that just don't exist anywhere, but you can just create a module from scratch, reloading, and the PYC byte files. I've got some links here to some documentation. This Git repository that contains my source code. If you guys want to look at that, it also has a link to this presentation if you want that. And then at the import hook I talked about, and then the code image tool that I use to generate the screenshots of my code. And then again, my GitHub and my Twitter. And that's it.
So thank you, Bryce. We have some questions here. So going from top to bottom here, first question, is it really possible to invalidate the module cache after the import to enforce that you are re-importing fresh?
Is it possible to validate the cache? I'm not sure.
Do you want to read it?
Read. It's possible to invalidate the module cache. There are a lot of gotchas and invariants that the interpreter has when reloading modules. And there's depending on what portion of the interpreter you're using, invalidating it may not be fully, let's go back here. Where did I put this? Where did I invalidate it? All right, yeah, so this reload function reloads the module, but it doesn't actually invalidate all the caches. It invalidates that cache. There are other caches that you need to invalidate manually to do this, and it's complicated, and typically you don't want to reload your modules unless you have a very contrived use case for it. So like the finders and loaders that are built into the interpreter have their own caches, and those are not implicitly invalidated by this reload statement. So if you want a true invalidation, you have to do some extra work. Next question.
Okay, the next question is, in what scenarios does it make sense to import modules manually?
If the modules are dynamically generated or they're passed in as like plugins per se, like there's some Django use cases where you pass a module name to some Django functions as a string, and then Django is responsible for importing those like plugins based on the string path. And so that's going to be doing some dynamic module loading using strings instead of the import keyword. So that's a use case. The other use case is that mature and import hook I mentioned earlier. Next question.
Okay, does the position of the import statements matter?
Well, you need to import it before you use the thing that you're importing. There's a question of, do you put the import statement at the top of the file or in a function? Usually you do it at the top of the file just based on like that's precedent, and also because every time you import a function, there is that cache lookup, because you have to check sys.modules, hey, have I seen this before? So if you have a tight loop in a function and you're importing within the function, you probably want to move the import out of the function if you can. But other than that, like the position doesn't really matter unless you have some gross thing with your functions that rely on the external state where you need to import one package before another. But again, avoid that. Okay.
Okay, so the next one, how can we ensure tests of production code with broken imports cannot magically pass thanks to caching? For example, import is somewhere in the test suite by chance. This one.
Tests of production code with broken imports cannot magically pass thanks to caching. Well, so one of the very hard problems of software engineering is cache invalidation, and that's just a problem you're going to have to deal with. Like, does someone have, like, whoever asked that question, do you have more information about what you're asking? Yes.
Oh, let me go to.
Yeah, it's actually like, it's very simple to explain, but it's a really strange issue. Is if you've got broken production code because of a simple import statement is broken, you can have tests of that, which if they run in the course of a test suite that somewhere else is importing the module that's not imported properly in the production code, the tests will pass when you run from that particular location. If you run from lower down, the individual test, it will of course fail because of the import. But this is because of this caching, right?
So you're saying that you have multiple tests that import a package, and there's something wrong with the import statement in one of the tests? And
you just have a piece of code where there's a broken import statement.
Okay.
And then you've got a bunch of tests that test a load of stuff, but somewhere in that test suite, that particular import is made correctly.
Okay.
In the tests. So when you run all those tests, yes, like just a broken piece of code. Like, it would raise an exception if you ran just that. If you have a unit test for just that function or something, it will fail. But then you run the whole test suite, and because it's imported somewhere else, it will pass. That test will pass. That code will pass. Does that make sense?
So, if I'm understanding correctly, you're saying that depending on the order that the tests are run, if the broken one is executed first, it will fail the test. But if the working one executes first, the other ones pass. I mean, yes. I don't know a context in which you'd have a proper import statement in one place and not another, where it fully resolves in one place. But if you were in that situation where, say, you imported a module, ran your test, and that broke the cache, and then they, like, not just invalidated it but broke it, and then that other import tried to. Sorry, we can talk after, but I'm not. Next question.
Yeah. So next question. This is going to be the last one. Are .pth files handled by the file finder? Let's start in the sys meta path. Should I create meta path fiber to increase efficiency in finding .pth content?
Unfortunately, I know very little about the PTH files, so I can't answer that question.
Okay, should I do another one? Okay, I think we are out of time, but okay, thank you everyone for joining.
Okay. Okay, good evening to everyone. I will be pleased to present Swastika Yadav that tell us about understanding the magic of Python modules and packages. And just a little reminder, if you want to go to some question, you have to use Slido, and you can find the link in the schedule page of the talk. And so you can use the app Slido, and then we have to do it. Okay.
Hello, everyone. Thank you for being here. I am Swastika, and I know there are a lot of amazing talks going on, so you all being here means a lot to me. So let's start with introduction. I am Swastika. I work as developer relations engineer. I create educational content on platforms like LinkedIn, Twitter. I enjoy traveling, and yeah. So, and for people who do not know what's developer relations engineer, so we are like the bridge between the company and the user. So we build applications using the company's product. We give tutorials on it. We write tutorials. We manage the documentation. We manage the community. We are also the maintainer of the open source projects or repos if we have any in the company. So this is the agenda looks like. We'll see what Python modules are, what is Python packages, how do we search module search path, how do we import modules and packages, what are sub-packages, how does it all work together. Like a lot of people use all of it in their daily code, but there's a confusion like what's the difference between a library, how does a framework work, what is modules, and how is module as a part of package or is this a part of modules. So we'll see that all together, and we'll also see what are the benefits of using modules and packages in our Python code. So we all have must seen this code, and I think everyone relates to it. Like when I wrote the code, only God and I understood it, but now only God knows what was happening in the code. So even if we wrote something like a week or a month back, and if we want to go back to it, we are blank. We don't remember what the logic we used at that particular time, how did we go about it, how did we debug it, what was our thought process. So yeah, so to have something, and how do we manage that long code, because having 1,000 lines of code in one file is extremely not next to impossible to understand every bit of it, especially when you're working in a big organizations where you have multiple people working on the same project. You cannot know everything. People work on different functionalities, you work on different features. So if you want to go make changes to a different feature which you have not coded from scratch, so that's difficult. So yeah, now let's see how modules and packages solves this problem. So let's go back a bit here again. We have two major problems. One is you do not have a proper structure when we have a huge line of code, and another one is you do not know where the particular code exists. Like if you want to, for example, in an e-commerce, you want to change something in the cart. If it's all in one file, that's impossible to do for somebody who has not written that code, or for somebody who has even written that code as well. And then, so yeah, these are the few things which modules and packages comes in the picture to solve. So for here, you can take an example of, like, for example, ABCD is a whole file, which is built of A, B, C, D. There are four different features or functionalities which are coded in just one single file. And if you want to make a change to A, there are high chances that if you make some changes in A, the whole code can break. Or if not, if somebody else who has not written or seen this code before might not be able to make changes to a particular feature. So what we did was for instance, A and B had some similar functionality. So we put them together. We made a different module called AB, and then we made another file called CD. So now we have two different files, AB and CD, which are the modules. And in modules, you can have script. It's just like a simple Python script. You can have classes. You can have variables, you can have functions, and anything and everything. So after that, once we have AB, then we thought maybe this could be, again, split into much smaller pieces and have smaller functionalities. Then we broke it down a further bit, which is A and B, C, D. So now we have 4 different functionalities. These are all can be integrated together. So if you want to make changes to A, their chances of getting the whole code broken is pretty much lesser than using all the 4 A, B, C, D in one file. So yeah, now we have, for example, now we have 2 different separate files. One is ABCD, one is GHIJ. So the first file has 4 features which are ABCD, and the another one goes similar, GHIJ. But we want to incorporate those different features into one file, so we can use those features ABCD separately with the another file, and we can have another file which could be named as GABJ, which can have the different functionalities of the first file and the second file. So you can use all. This shows the reusability of the modules, how they can be used, and how flexible we are when we have when we have broken our code into smaller pieces. Because if we had one singular file, which was ABCD in one file, and that it was impossible to use those functionalities again in another file or in another code. So what's packages? Packages are nothing but the group of modules. For example, here we saw these are different modules. So if we group together A and B, because they have similar functionalities or properties of maybe working on some particular design or feature, they can be grouped together. Because then further down, even if they are grouped together, they can be used separately, like A and B, and they can be used together as a package, which will have obviously more functionalities and features. So this is how a package look like. So it can have multiple. These are the 4 multiple modules here. And if you see this is a package. So you can have multiple modules in a package. Then you can store that package in another package, which of course will increase the functionality and the features. So you can have as many packages you want inside a package, which are called sub-packages. And then you can, inside a sub-package, you can again have modules or packages. So this is an example of simple bookstore app where you can buy books, you can see what the authors have to say about book, what are the books there, and what you can log in, you can log out, you can log in as a user, or you can log in as an author. So yeah, so if we have to build everything in one single file, it's just next to impossible. If we have to route everything in one file, we have models which, so here models will, and yeah, so one more thing. When we have packages, the difference between module and packages is we have to define and it can be an empty file, but you have to define a init.py file so that your interpreter knows that it's a package and not a module. So you define an init file, it could be empty, and then you can have multiple packages or modules inside that particular file. So in models, packages, we will have books, we will have authors, we will have users. In books, we will see what's the title of the book, what's the rating of the book, what's the genre of the book, and then in authors we will have the name of the author, nationality, what kind of books he or she writes, and yeah. And in user you can have their login information, their username, their whatever else information is required for somebody to create an account on the website or on the app. So in routing, again, in routes we have a sub-package inside user routes. So in user routes, we can have another user management tool where a user can change their settings if they want to maybe use dark theme, light theme, what would be their shipping address, everything could be inside this. And then we can have further more modules and packages inside this as well. In services, we will see like what if we can make changes to the books, we can add information to the books, we can remove books, we can add more books. In author, again, we can replace an author if somebody has co-authored a book, or somebody made changes to their book or in their bio, that all can be updated here. And then in tests, so another good thing about using modules and packages is you can test every single package independently, and it wouldn't affect the whole functionality of the whole product. So you can test the author routes here, you can test the authors, you can have multiple more modules and files inside it, so see what else, everything you want to test separately. Okay, so let's see, how do we import a module in a file? So here we have a simple function. One is the first one is adding two numbers. The second one is subtracting two numbers. So this is a small example, but for example, you have a fully functioning calculator. So there you will have percentage, you will have multiplication, you have division, you have square roots, and a lot of more math functionalities. So if you want to and having everything in one code is again a hassle. So we'll have different functions inside a module, and then we'll import this in our main file, which is we just use the syntax import, and we just import the file here. And if we run this, okay. So yeah, we have the addition here, then we subtracted it. But again, using, there could be like 10, 15, hundreds of functions inside a module. So it would make the optimization not that much great. So we can just import a single function as well, which we just want to use if we see it here. Like for example, we just need to use add, we do not want to use subtract, so we can just import from module and import, we will just import the function add here, and if we run this one, we will have the addition of this. So you can have multiple functions inside a module, and it depends on you how many functions or you want to use in that particular area. So there's one more syntax where you can have a list of functions which you want to use in a particular file, and instead of using all the functions inside of a module, you can just choose the ones which you are going to use in a particular file. Okay, and for packages, yes, as I mentioned, you have to have init so that your interpreter knows it's a package and it's not a module, because there's no, like, the syntax for saving a module or a package file is similar. So yeah, that's how we import the modules and packages. Now, once that we have imported the modules or packages, there's a way of how the execution of the program will goes, and how the interpreter will know what module you have imported and how will it search. So the first thing is it's going to go to the current directory. So if you have the module there you go, you have the you'll find the module there. Then the next thing is, so you just import sys and you print it. If I run this, so you have the whole, like what's the directory, what's the path for how the files are saving in your system, how it's all working. So we'll just make it much cleaner. Just maybe remove this one. So this is how our whole directory looks like. We can make changes to it, but generally, if this is how the default setting is. So if you want to see where you have to have your modules, some modules or packages inside this, and the other, the Python path environment variable is the another, like it's you can think of it as a storage container inside a warehouse where everything is already labeled, and you just go. You do not have to search the whole warehouse. You know which module you want to search. Your interpreter knows the name. It will just go and search for it. So if it doesn't find the your module inside the environmental variables, then it's going to go to a standard library, which are automatically downloaded when you install Python in your system. So, and then last is site packages. So even if we do not find the module anywhere, then it's going to give you error that module not find. So in that case, there are chances that you have made a typo or something, or you do not have a module. And in another case, there could be chances that you saved it somewhere else, which our module search path cannot figure it out. So what we can do is we can change the module path. So there are two ways to setting the environment variable. One is temporary, which is like it will work only for your current session, the code you are running at that particular time. And another one is permanent environment variable, where it will be changed forever. So every time you do not have to change it, once you change it, it's done and dusted. So for changing it temporarily, you just have to run this command, and your modules will be changed. Okay, I've already changed it. So that's how you can have Python path, and you have your username, and whatever the directory you want to save it, you save it like this. But this will only work for this particular session. Once you close the terminal, it's not going to work anymore. So for that, you have to change it in the permanent environment variable. To do that, we have a few things to do. First, we figure out which terminal we are using. Are we using Bash or we are using Z shell? So for example, I'm using Z shell here. So we have to go inside the Z shell terminal. And once we run this first command, we are inside the terminal. And then we again have to define the path. This would be different on your local system. Once you define the path, you save you save your file there, and then you run the source of ZSHRC, and that's how the path is changed forever. And you can further change it as well, but for this one, that's enough. Okay. So let's just see this one as well. How does it all work together? So if you are building a house, you can think of modules are the bricks, which are like the building blocks of your house. These are the smallest structure, but these are very, very necessary for the whole final output. So once these are packaged together, we can have it like a palette of bricks, which would have a similar functionality. Like, for example, here it could be used to build a bedroom. And when we relate it to coding, it could be used for a particular functionality or a feature in a website or in a web application. And then libraries are the building blocks. Like, you have to use the modules and packages, but the libraries will make sure that you have the right tools to use your modules and packages and build something out of it, because the bricks and pallets of bricks is not enough to build a complete house. Then we have framework. Frameworks are predefined. Like for modules, packages, and libraries, they can be changed. We can use it on our terms, how we want to use it, how we want to structure it. But when it comes to frameworks, those are predefined. They have structures, they have rules. You cannot change them. You have to use that in your project according to what's stated in that particular framework. For example, Django, Flask. So you cannot change it, but you have to then you use the libraries, packages, modules inside it according to like how you want to use it, and then that's the home is your whole application. Benefits of modules and packages, of course, reusability, because one file cannot be used anywhere else. If you have if you have broken down your code into smaller pieces, you can use it in different code bases. You can use it at some other place. The reusability of that particular code could be increased, and you can use it anywhere else, wherever you want to use it. Then, maintainability, yes, of course. Once you have smaller pieces, everybody who does not even have access to your code and reads your code for the first time would still can make out where the namespaces is, what the variables names we have used, and can go through it if they want to change any particular functionality inside your code. And code modularity, yeah, again, as I mentioned before, if you have smaller files inside one big project, they can be tested independently. You can make changes to it. It would not affect your whole applications. There would be, even if that code breaks, there are less chances of breaking the whole code base, and you can just maybe debug it and fix that particular module or package there itself. Scoping, so if we have like one big file, then you have to use different names, you have to use different variable names, different classes, different file names every time. But if you're using modules, then you can have similar name of variables in 2 different modules, and it will have a different scope, so it would not jeopardize your whole code. So yep, that's about it. And thank you for being here. And this is my LinkedIn and Twitter. You can connect me by scanning this one. And yeah, thank you so much.
Okay. If anyone have a question, we can, because I have no question on Slido. If someone wants to pose a question live, I can give you the microphone. A question? Okay.
What are classes? Is it does it have something to do with modules and packages?
No, it doesn't. A module can have anything inside them. So it can have classes, it cannot have classes, it can have variables. So that classes is a whole different concept of OOPS program. So it's a different field. So it can be included in modules or packages, but yeah, it's not related to it.
Other question? Okay, so let me to thanks again our speaker. Thank you. And
yeah, I'd like to add one more thing. I'd like to thank PyCon Italy for their diversity grants and their sponsorships, which can make it possible for us to come here, and for flying me all the way from India to here. So thanks a lot for that.